Good morning, friends. Today we are coming up with one new topic. In fact, it's not new. We have had some glimpse of it during the different control structures for soil and water conservation. And today we'll be dealing exclusively with bunds. So bunds devices, vegetative waterways. These are farm ponds. These are some of the conservation structures which are constructed in the agricultural land, that is the land which is suitable for cultivation class 1 to class 4. And specifically talking about bunds are generally constructed in class 2 type of land where the slope is milder and the soil type is good. It's not that bad, it's good. Slope would be around 2 to 6%, and soil type would be a combination mixture of all the ruby sandy loam and silt loam type of soil. Here, in such type of soil, we construct bunds. Now, coming to bund are many types. And firstly, what is a bund? Bund is generally refers to an embankment of earthen embankment which is constructed across the slope of the land so that the water is retained in the upstream side of the bund. When water retains there for a sufficient amount of time, it will allow the water to infiltrate. It will give enough opportunity time for water to infiltrate into the soil. So as a result, the crop which is grown in the upstream side of the bund, there would be enough moisture content, and also it will augment the groundwater table by if you conserve the water, if you pond the water in the upstream side for sufficiently long time, there will be infiltration, and as a result, the water regime of the soil will increase. Since it is an earthen embankment, there is cutting of the soil from the upstream side, as we see in this this photograph. This soil is excavated and it is put on the bund side, and the bund side in a trapezoidal section. Trapezoidal section, why? Because it is more stable. At a certain height is decided in the design depending upon the amount of water that has to be retained, and also it depends upon the type of the kind of rainfall or runoff it has to withstand. Since it's a temporary structure, there's no cement or stone involved in it. Rather, in some places stones are also used when it is cheaply available as a bund. Stones can also be used, then we call it stone bunding. So it is, the shape is generally trapezoidal, and this rectangular square excavation of water earthwork that you see, it is just for simplicity, to make it more simple to calculate the volume. Generally it is manually excavated these days, although advanced machines like JCB and JCBs are used. This is like 10 feet by 10 feet, that is one chauka, what we call it in vernacular language. That is for ease of calculation or for making the payment to the labor. So it's one person will cut this much. It is expected that one person will cut this much of chaukas so that they can calculate the man days and the wages. So this is a photo of a bund. So bund basically consists of an embankment which is trapezoidal in section. You don't be very particular about the words like embankment, cross section. Basically, what is bund? Bund is something which has been constructed from times immemorial. Whenever there was agriculture was always done on the plain, on a leveled surface. For that, bunding was very much required. It has been continuing from many years from our forefathers. So it's in local language we call it made, right? This bund is nothing but made, and it's an embankment with trapezoidal section. So depending upon the material that we use, bund can be stone bund. If stone is available in large surplus quantity in the area, with if not too much cost is involved, then we can use stones to construct the bund in that trapezoidal section. Why trapezoidal section? Because it will be more stable if you construct it in a trapezoidal section with side slopes. Otherwise, if you construct it vertically, what will happen? It will overtopple if there is high amount of rainfall or if there is pressure. So this is found different types, like this is contour bund. And why we call it contour bund? We will be discussing in types of bund. What are the different types of bund? Contour bund and graded bund. When the bunds are conformed to the contour of the area, then we call it as contour bund. And contour bunds are essentially constructed to conserve the to make the water stand in the upstream. And since it will be on the contours, there is no sideward slope, no gradient, so there would not be any movement of water laterally. The water will not move from the sides of the bund, right, in the lateral direction. Whatever water is coming from runoff, that is the excess rainfall, it will be stored in the upstream side of the bund. So graded bund are one where we give certain grade along this contour. If this is a contour bund which conforms the contour of the area, in graded bund a certain grade is given, so that if there is excess rainfall, and if there is excess rainfall, because the bund will be of certain height, if there is excess rainfall, the bund may be distracted because of the high water pressure. So what we do is we give a gradient. Generally 1:100 or 0.5:100 means there would be level difference between, if we go 100 meters, there will be a difference of level of 0.5 or 1 meter. So that is gradient, and that is called your graded bund. And graded bund are constructed in medium or heavy rainfall area, and contour bunds are constructed in low rainfall area. To be very precise, wherever the place wherever the rainfall is less than 600 mm, then we go for contour bunds. And these contour bunds are more popular in states like Gujarat, Maharashtra, parts of Madhya Pradesh, parts of Karnataka, and Tamil Nadu, where the rainfall, at patches where the rainfall is less. And graded bunds are constructed in places where the rainfall is medium or heavy, like places like Jharkhand, Bihar, and many other Himalayan places. We go for the graded bund, where we along with the bund we give a certain gradient, so that if there is, in the event of excess rainfall, the rainfall will pass away from the side, from these grades, and can be carried to a safe velocity through some waterways or some nalas, or through some weirs. Now this is what we were discussing, types of bund. It is contour bund. So contour does not necessarily be in a straight line, because in a field, the contours, the value of points of equal elevation may be in a zigzag pattern. So these are the contour bunds. So that means at each point the elevation is same, right? These are constructed along the contours. Earth from the upstream side are excavated and put on the downstream side in a trapezoidal section with some allowance for subsidence. Like when you put loose soil, after rainfall it will subside. That is, the height of the bund will decrease. That thing has to be kept in mind. If your designed height is say 1 meter, then you have to go maybe 1.2, 1.3 meters, so that if there is rainfall, because loose soil, dry soil would be, pore spaces would be high, and if there is rainfall, due to the effect of rainfall, there would be subsidence, there would be decrease of height. So this factor has to be factored in. Second type of bund is, and this, as I have already told, that this is for areas with less rainfall. Rainfall lower than 600 mm per year. Second, this is the graded bund. You see these are the contours, but instead of going for this is your field boundary, and these are your bund, and along the bund you give certain gradient. Gradient means some slope, you give some slope so that the water, excess water which the bund would not be able to handle, or the design dimension that we have designed for this bund, it may not handle that amount of water pressure. To take care of this aspect, a grade is given so that the excess water will flow to some waterways, and it is drained out through some waterways or through some drainage channel to some small rivulets. So your bund will be intact. It won't affect much with the higher intensity of rainfall. So here bunds are constructed and some grade is given. The problem with contour bund and graded bund, especially contour bund, is the area lost, because the contour bunds does not conform to the field boundary. By field boundary I mean the area demarcated by the farmer's field. So farmer's field may have this type of chunk of land, but if we suggest them to go for contour bunding, they might not agree. They might not agree because, see, we have to construct, technically speaking, if you have to go for contour bund, then your bund could be anywhere in the farmer's field. See, some portion of the land is very narrow where they cannot cultivate. So area lost in contour bund is little high. So, and the land required for making the embankment is also has to be factored in. So this is not very popular just because of this, because farmers does not want to do away with their land. So they want to cultivate in every chunk of land. So that is one of the problem with contour bund. That's why that is one of the reason why it is not the area has not increased under contour bund over this last 10, 20, 30 years. So what they prefer is they want these bunds along their periphery of their land. So suppose this is a chunk of land that one farmer is having. They want bund along their field boundaries. So such type of bund we call it field bund. And if they do not agree with contour or graded bund, then we have to go for the field bunding. And again, the field bunding, you have to take care of all the things. The design aspect has to be taken care of. What should be the height, what should be the bottom width, what should be the top width. This is another pictorial view of graded bund. See, from a higher slope water is coming and it is getting deposited here and stored here, and there is certain grade given so that the excess water, instead of ponding at one place, that is drained away from the sides of the bund to some drainage or to some rivulet or some outlet, and such type of bund we call it a graded bund. Now another advantage of contour bund is it not only pond the water and increase the infiltration rate, it is also useful for soil erosion control. Like if water is coming from the upstream side and getting ponded across the barrier of this bund, what will happen, along with the water, it will also carry the soil, that to the top soil, and the top soil will be deposited here. And as a result, over a period of time, the steepness of the slope, the slope of the land is gradually reduced because of deposition of soil particles from the upstream side. That is another added advantage with, be it contour bund, be it field bund, or be it graded bund. So there are certain design consideration for this contour bund. This is a pictorial view of section of contour bund. So this is your slope, existing slope, and these are two consecutive contour bunds. And the distance between two consecutive contour bund is the horizontal interval, and the difference in elevation between two, that is difference is height between two successive contour bund, we call it the vertical interval or the height. This is one contour bund and this is the downstream contour bund. So what will happen, water from here, water and soil from here will be deposited here against this embankment, and water is will be ponding here, and along with water some amount of soil is also coming and it will be deposited here. So over a period of 2, 3, 5 years, what will happen is this gradually steeply sloping land will be converted into rather gradually sloping land, because of, for the simple reason of deposition of soil particles in the upstream side of the bund. And this is the section of your bund. It has got a trapezoidal section. It should be having a bottom width, it should be having a top width, and there has to be one side slope. In the here it would be little difficult to show you what is side slope and what is, how bottom width, top width are calculated. We'll for 5-10 minutes we'll go to the classroom as well for after some time. So side slope is the the horizontal is to vertical. Say suppose this is your land slope, this is your horizontal and this is your vertical. The ratio it makes with the vertical, the horizontal makes with the vertical is your side slope. Side slope of 1:1 mean if we go 1 meter horizontally, the difference in elevation vertical distance would be 1 meter. If we say the side slope of 2 meters, like here the side 2 meters, it would mean 2 meter horizontal distance to 1 meter vertical. It's always H is to V, not the other way around. It's H is to V, horizontal is to vertical. So this section we can see, this is your bund, and also if you observe this figure, the upstream side, the side slope is more steeper than the downstream side. If upstream side is say 1.5:1, the downstream would be 2:1, although it depends upon the type of soil. Say in the heavier soil, steeper side slope, say 0.5:1, that is 0.5 horizontal to 1 vertical, or 1:1 is fine. But for sandy soil, that too depend upon the type of the soil, be it alluvial or red soil, the horizontal, this side slope would be higher. And this is your ponded water. From here infiltration take place, as well as soil deposition will be taking place at the foothill of your embankment. And one very important thing is the seepage. Whenever we design a contour bund or any conservation structure, like if many of you might have studied in soil mechanics, like the seepage in a earthen bund, earthen dam, what happens is this seepage, like if there is continuous ponding of water, water will seep in the embankment, and it will go and it will move along the embankment. This seepage line has to be taken care of, and this seepage line should always pass through the bottom at the downstream slide. It should not be like this. If the seepage line goes like this, then there would be underscoring of the bund and bund will be damaged. So it is very imperative, it's very important to keep the seepage line within the downstream side slope, right, base of the downstream side slope. And these are certain design considerations like spacing between bunds, side slope, seepage line that we have already discussed. Grade is generally for graded bunds, where we give a grade so that the excess water is drained out through to some outlet in graded bund where the rainfall is high. Then height of the bund, what should be the optimum height of the bund? There is some formula that we have to derive. Then the cross section, anything, if any piece, a rectangular thing or a trapezoidal thing, cross section would be length by width right? So that cross section has to be decided. What should be the ideal cross section of the bund? Generally, for Indian condition, the cross section should always be more than 1 square meters. And freeboard, to discourage the overtopping of the bund, like if you design the bund, will not allow the water to stand till the full tank level. Will allow some freeboard as a factor of safety, and this freeboard is generally 20% of the height of your ponded water or height of the bund. So these are certain design consideration which we will do in 10-15 minutes. We may be able to complete it. And there is one more structure that we won't be discussing today, that is continuous contour trench, and this is something is very much popularized by the forest department, especially in the high reaches, and where whatever structure, be it contour bund, be it terracing, the effectiveness of the bund will be highly enhanced if you reinforce your bund in the upstream with such type of structures. And this is generally done in non-cultivable area like class 5, 6, 7, and basic purpose is to store the excess runoff in these pits, so that the pressure on the bund is less, and also the because of ponding of water in these pits, there would be infiltration beneath the soil, and this soil moisture will reach to the downstream side where the contour bunds are constructed. Now let's talk about the design of contour bund. We will be going to the class for this. Some explanation is required for that. Over to the class now.